Use asymptotes and intercepts to match the function with its graph. We are given the function f of x equals x minus 6 quantity divided by quantity x plus 3. Well, first we can look for vertical and horizontal asymptotes, which are shown on these graphs as dashed lines, very typical. A vertical asymptote will occur when our denominator is equal to 0. So this would be x equals minus 3. That's the value of x that would make our denominator 0 with this function. So we should have a dashed vertical line at negative 3. Okay, so the second from the right graph is not correct, and the first graph are not correct. So these two cannot work. Now let's find a horizontal asymptote. So our degree of our numerator is 1. The degree of our denominator is also 1. So we'll need to take the ratio, our leading coefficients. Our leading coefficients are 1 and 1 respectively. So this would be 1 divided by 1, or 1. So we have a horizontal asymptote at y equals 1. So we'll have a horizontal line at y equals 1, which does not match with our last graph. So this second graph here must be it. It has a horizontal asymptote at y equals 1, a dashed line at y equals 1, a vertical line at negative 3 that is dashed as well. And actually, we could find the x-intercepts, but we don't actually need that here, so we'll leave that alone. The x-intercept would be when the numerator is 0. Well, actually, the x-intercept would be when the numerator is 0, so that would be x equals 6. So the point 60 is the x-intercept, which does match with this. Now let's look at our last function and graph. Use asymptotes and intercepts to match the function with its graph. F of x equals x squared minus 16, that's our numerator, divided by x plus 2 quantity, that's our denominator. Alright, well, for vertical asymptotes, well, let's go ahead and factor this. This would be x plus 4, x minus 4, all divided by x plus 2. That denominator will be 0 when x equals minus 2. So we should have a dashed vertical line at minus 2, which does not match with the first graph. It has a dashed vertical line that is in the positive x direction. Same thing with the last graph. Potentially that's negative 2 or positive 2, but that doesn't match. All right, let's see. Our horizontal asymptote, well, the degree of our numerator is 2, and the degree of our denominator is 1, which means we might have an oblique asymptote or a slant asymptote. So let's do the long division off to the side. That actually won't help us here because both of these have a similar characteristic. We'll go ahead and do it anyways. Let's see. Do x squared plus 0x minus 16, missing term there, divided by x plus 2. X multiplied by x would be x squared. Now multiplying x times the x plus 2 will be x squared plus 2x. Put that in parentheses and subtract it. We get minus 2x, bring down a minus 16. X multiply in our divisor would need to be multiplied by negative 2 to get a minus 2x that we have there. So minus 2. Multiplying negative 2 times x plus 2, that is minus 2x minus 4. Putting that in parentheses and subtracting it, we get minus 12. So our oblique asymptote is the line y equals x minus 2, which both of the two remaining graphs have, so that doesn't help. However, we can find the x-intercepts. The x-intercepts occur whenever the numerator is 0, which from our factored form we can see is negative 4 and positive 4. So negative 4, 0, and positive 4, 0. That is not going to happen on the first graph, but that will happen on our third graph. So that is our function based on characteristics of asymptotes and intercepts.